Hello students, welcome to Learner's Planet, Theory Session 5 of Carbon and its Compounds. I hope you have understood the properties of carbon as well as the hydrocarbons and the chains and the types of compounds they form. I was explaining you the rules for the IUPAC nomenclature of hydrocarbons. In this session, we will be discussing the IUPAC nomenclature in details, as well as we will discuss few examples. Now let's start with the rule of this IUPAC nomenclature. It says that the alkyl group present as the side chains are considered as substituent and named separately as methyl or ethyl groups. The position of alkyl group is indicated by writing the number of carbon atom to which it is attached. If you remember students, in my previous session I took one example, and in that I was writing the substituents as a primary prefix. Here I'll also take one more example so that this concept is clear to you. Students, I'd like to tell you this is the basics of organic chemistry. This is the basics of nomenclature, and you should be through with all these things. Now in this I'm taking again a carbon chain. Let's take this carbon chain. So what I'm doing is I am just writing the carbons. I'll write CH. That would be better. Say that is CH3, this is one chain, CH2, CH2, CH, and to this a substituent is present, that is CH3. Again there is CH2 and CH3. Now first of all what you have to do is you have to number the chain, or you have to select the longest chain. Let's start numbering. If I'm starting numbering from the left hand side, what I'll get is 1, 2, 3, 4, 5, 6. And if I am taking another chain, that is quite possibly if I'm taking this chain, 1, 2, 3 and 4. So which is the longest possible chain, students? The longest possible chain is this one. So this is your longest possible chain. Now in this longest possible chain, how many carbon atoms are there? There are 6 carbon atoms. So what would be your root word? Just tell me, what would be your root word? It would be hex. So I'll write here root word. It would be hex. We find out the primary suffix. How? By finding out the nature of bonds present between the carbon atoms. So I'll write here primary suffix. Whatever bond is present between the carbon atoms, it's the single bond. So what would be the primary suffix? It would be ane. Now there is a substituent present, that is, which is a methyl group, as this rule says that alkyl group present as a side chain are considered as a substituent and it should be named separately. Now where to give this number? I can number from right to left hand side, that is this, or I can number from, this one is left to right, or I can number from right to left. Okay, so this chain is ruled out. What I can do is, if I am numbering from right hand side to left hand side, what I'll get? This is the first carbon, this is the second one, this is again the second, third, fourth, fifth and sixth. Now in this case, children, which carbon, from which direction the carbon to which the substituent is attached is getting the least number? From left to right, the carbon to which the substituent is attached is getting what? Number 4. So, and from right to left, this carbon is getting number 3. So, the carbon to which substituent is attached should get the least number. So what would be the prefix here? What would be the prefix? I'll take it as 3 and methyl. Because there is one carbon, so it is what? Methyl. Now compiling all the 3, what will be the name of this compound, children? Its name would be 3-methyl hexane. So is my point clear? That the alkyl group present as a side chain is considered as a substituent and named separately, and this is what? This is a prefix. The position of the alkyl group is indicated by writing the number of carbon atom to which it is attached, and that the carbon to which the substituent is present or is attached should get the least number. We'll take few more examples, I think then it would be clear to you. The carbon atom of the alkyl group is numbered in such a way that the carbon atom to which the substituent group is bonded gets the lowest number. I'll take another example here so that this thing is fixed in your minds and it is very, very clear to you. Say I'm taking this example again, a long chain CH3, CH2, 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 I'll put one substituent here, that is C2H5. Now what I'm supposed to do? First of all, if I am asked to name this compound, what am I supposed to do? First of all, select the longest chain. The longest chain is obviously this. Then count the number of carbon atoms. So how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 carbon atoms. So what I have got in my hand? I have got a root word here. What is the root word for 8 carbon atoms? It is oct. Now my next step would be to find out the primary suffix. So what type of bonds are present between the carbon atoms? They are the single bonds. So what would be my primary suffix? It would be -ane. Now there is a substituent. Substituent here is this ethyl. So that should be the primary prefix. Now what is my duty? My thing is that I should assign some number to the carbon atom to which this ethyl group is attached. Now let's start counting from both the sides. First of all, let's start counting from left to right. What it would be? So it would be 1, 2, 3, 4, 5, 6, 7, 8. Okay? And let's start counting from right to left and see what all numbers we are getting. What all numbers I am getting here. So it should be 1, 2, 3, 4, 5, 6, 7 and 8. Now from which side the substituent carbon is getting a less number? When I am counting from left hand side to right hand side, the carbon to which substituent group is attached is getting number 4. So what should be my primary prefix here? So my primary prefix should be what? It should be 5-ethyl. No, it should be 4-ethyl. So what should be the name, students? It should be 4-ethyl. Now what would be the complete name of this compound? The complete name would be 4, my primary prefix ethyl, and in continuation octane. So this is the way how we name a hydrocarbon with a substituent. I hope this is clear to you. What you can do is that you can make chains like this and practice nomenclature. Let's take up with the next rule of this, that is, the IUPAC name of the compound is obtained by writing the position and the name of alkyl group just before the name of the parent hydrocarbon, which we did. The substituent groups should be written in alphabetical order. Now what is this? This is the new thing. I'll write one more example here. I can take the example of, again we'll draw one chain, that is CH3, CH2, 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 CH. I'll put one substituent here, that is C2H5 and CH3. I have to put one more substituent so that you are getting this concept clearly. That is, I can make a methyl group here, but then my carbon has become pentavalent, I suppose. Yeah, it should be CH. Now for naming this root word, you decide what is the root word. How many carbon atoms? 1, 2, 3, 4, 5, 6. What would be the root word? It should be hex. My primary suffix ane. Why? Because there are single bonds between the carbon atoms. Then I have got two substituents here. What was the thing that for deciding the primary prefix, what we did was we just we just assigned the number to the carbon atom and wrote the group. But here we have got what? We have got two substituents, one methyl and one ethyl. Now that has to be written in alphabetical order, students. And the number to the group should be least number to the one which is coming first. Say if I am starting counting, I am counting the carbon chain from left hand side to right hand side. What are the numbers am I getting? This is 1, 2, 3, 4, 5 and 6. Likewise, I can start counting from right to left. I'll write it in a different color. What are the numbers am I getting here? 1, 2, 3, 4, 5, 6. Now you decide. I have written here the substituent groups should be written in alphabetical order. So you decide which comes first, ethyl or methyl. Obviously in A, B, C, D, E comes first. So which should be written first? Ethyl. Which carbon should get the least number? The one with the ethyl, because the one which you are writing first should get the less number. So our primary prefix would be what? Would be 2-ethyl and 4-methyl. Now compiling all these, what would be the name of the given compound? It would be 2-ethyl, 4-methyl and what? 2-ethyl, 4-methyl separated by a comma, and we have got our hexane. So this would be the name of my compound, the example of which I have taken. So I hope you can write the names. This is the way we do the nomenclature. Now let's take up few examples here, just to check whether you can name it or not. This is what? This is 2-ethyl propane. Is this clear? To the second carbon there is an ethyl group. Ethyl can be written as C2H5 also, and it can be written as C2H5 also, and CH2CH3 also. This is one more example here. This compound, I have not written its name, I have just numbered it. Now what will be the name of this compound? So I don't think I need to write all the things again. What would be the root word? How many carbons you can observe here? It is hex. What is the suffix here? Single bonds. So it would be ane. How many substituents are there? There are 1, 2 and 3 substituents. So it is 1, 2 and 3 substituents. How can I write there it as a prefix? So it would be what? To the second carbon, 1 methyl group is attached. So it should be 2-methyl. Again 2-methyl. And then there would be 4-methyl. So despite writing this 2-methyl, what I can write is 2, 2 dimethyl, and again there is 4-methyl. Now all the methyl groups are there. So can I write it 2, 2, 4 trimethyl? Right. So our prefix would be this. Now what will be the name of this compound? It should be 2, 2, 4 trimethyl hexane. Now you can also say that why we are not numbering from the opposite side. That is, in this case the numbering is from left to right. If I number the same compound from right to left, what all are the numbers I can assign? 1, 2, 3, 4, 5 and 6. Then what would my compound be? It would be 3-methyl. I can number it from that side also. And its name will become what? 3, 5, 5 trimethyl hexane. But this is wrong, students. I'll tell you why. In my next rule, I'll tell you why it is wrong. Here only I'll tell you why it is wrong. There is one more rule, that the sum of the numbers assigned to the carbon atoms with the substituent should be the least. The sum of numbers assigned to the carbon atoms should be least. So this should be least. Now what does this mean? That, say in your first thing here, it is 2 to 4. What will be the sum of these numbers? It would be 2 plus 2, 4, 4 plus 4 is 8. And in the second case, what would be the sum? It is 3, 5, 5. 3 plus 5 is, 8. 8 plus 5 is 13. So that is why this is wrong. Now let's take up the next example. This is what? 2,2,5 trimethyl octane. It is correct. Whereas when the numbering is from which side? Is from left to right. So what am I getting is, I am getting 2,2,5-trimethyl octane. But when the numbering is from right to left, what am I getting? I am getting 4,4,7,7-trimethyl octane. Let's sum up the numbers again. Here it is what? 2 plus 2 plus 5. What am I getting? 9. Here it is 4 plus 7 plus 7. What am I getting? 18. That is why this number is wrong. So while attempting such a sort of question, students, what you need to remember is, you have to remember all the rules. They should be written in alphabetical order. The one which is written first should be assigned the less number. Then the sum of the substituents, the sum of the numbers assigned to the substituents. Yeah, this is that rule. The sum of the numbers assigned to the carbon bonded to the substituent group should be the least. This we have discussed. 2-propyl heptane. Count the number of carbon atoms. It's 6. And the number assigned is 2. This is the correct name. 6-propyl heptane. How I'll get this name? I will get this name if I am counting from right to left. So what am I getting? I am getting 6-propyl heptane, which is a wrong name. Why? Because there was one more rule, that the carbon to which a substituent group or substituent is bonded should get the least number. So that is why your second name is wrong. Now let's take few more examples. Yeah, this. So taking this chain, how many carbon atoms are there? 8. What would be the root word? Oct. Whatever bonds are present here, single. What would be the suffix? -ane. What are substituents present? C2H3 it should be, not C3H2, because in this case your carbon is becoming pentavalent, so it should be C2H3. Now what are the substituents present here? This is ethyl and this is methyl. Alphabetical order, which comes first? Ethyl, E. So E should get the least number, that is 2 ethyl, 5 methyl octane. But when I am numbering from the right hand side, what am I getting? So what am I getting here? I am getting 4 methyl, 7 ethyl octane. That is this thing. 4 methyl, 7 ethyl octane. Is it correct? No. Because the group which you are writing first should get the less number. So it should be, and also this are not written in the alphabetical orders. The group which you are naming first should get the less number, and the substituent should be present and written in alphabetical order. So this is wrong. Now in this case also we have got 3 groups here. C3H7 is propyl. C2H5 is ethyl. And CH3 is methyl. Right? So while writing the name, what you have to consider? Which comes first? E. Then what? Then P. and then M. So the numbers should be assigned them accordingly. Less number to E, then to P, then to M. So this is what? 5-ethyl, 7-propyl and 2,2-dimethyl octane. Now students, remember here, you will not consider this D. Okay, this D is coming first, so it should get the less number. What are you going to consider is M. So here D should not be considered. While naming, what should be considered as M. So for writing in alphabetical order, what should be there is M first. So what would be a name? 5-ethyl, 7-propyl, 2,2-dimethyl octane. Is this wrong or right? We are getting M and we are assigning it the least number. To which compound the least number should be assigned? So this is incorrect. This is wrong. What should I do? Because here M is the last one and we are assigning it the least number. So what should we do here is we should start numbering it from the right hand side. Right, so I'll get here 1, 2, 3, 4, 5, 6, 7 and 8. Now what am I getting is, I'll write it in the alphabetical order, but I'll write first what? 4-ethyl, 2-propyl, okay, 7,7-dimethyl. So this should be correct because your ethyl is getting the least number, which is possible in this chain. So this is your correct naming. But if you are going for the sum, let's sum up. So let's sum up here. This is what? 5 plus 7 plus 2 plus 2. What I'll get? 5, 7, 12 plus 2, 14 plus 2, 16. Here what am I getting? 4 plus 2 plus 7 plus 7. 13 and 7 is 20. Right? Now what are you going to do? We have got this sum is less and this sum is more. But here less number is assigned to ethyl. So what you will do here? In this case, you have to take the substituents which have got the least number, in which the sum is the least. Getting my point? So in this case, what is correct is this. So your numbering is, this one is correct. Got my point? I wrote it because these are the general confusions which students come across. So what is of most priority if the alkyl groups are the substituents is the sum of the numbers. It should be the least. I hope this concept is clear to you. So this is the same example, but in this case again see what mistake has been done here. Is it in an alphabetical order? Yes, this is in an alphabetical order. So it should be 4-ethyl, 7,7-dimethyl, 2-propyl, octane. But what has happened here? Again the sum is more. So this is wrong. In this case, this is also not written in an alphabetical order. Now moving to the next. Yeah, this is draw the structures of N-pentane, isopentane and neopentane. N-pentane means normal pentane where there is no branching. So this is N-pentane. Its IUPAC name is pentane. Then is isopentane when there is a single branching. and its name would be, at which carbon the substituent is present? Second carbon. So it should be 2-methyl-butane, right? Or it is also called as isopentane. Then this one is 2,2-dimethyl-propane, and its common name is neopentane. Likewise, you can draw the structure of N-octane, isooctane and neooctane. Let's draw. Say N-octane. N-octane will be a simple chain. So it would be what? It's a simple chain. That is CH3, CH2, CH2, H2, CH2, CH2 and CH2. Isooctane would be what? It would be CH3, CH, CH3, then CH2, CH2, CH2 and CH3. 8 carbons, 1, 2, 3, 4, 5, 6, 7 and 8. So this is 1, 2, 3, 4, 5, 6, 7 and 8. This is isooctane. And how will you write neooctane? Neooctane, that is, it will have 2 branches, right? So try to write the formula of neooctane yourself, okay? Now for this session I'll conclude, students. In our next session we will be meeting with few more rules of IUPAC nomenclature and how to name the functional groups if present. Thank you very much for listening patiently.